Just waiting for the presentation to load. Okay, so before we get started on the unusual properties of water, we need to take a hot tick to make sure we've sorted out the difference between ionic bonds and covalent bonds. We'll be dealing primarily with covalent bonds in this biology course, but an ionic bond is how two atoms are held together in a molecule in which one electron is transferred from one atom to another, like in sodium chloride. Covalent bonds are when electrons are actually shared between the atoms. And like I said, our primary bond that we'll be talking about in biology is the covalent bond, the sharing of those electrons, especially in water. So let's watch this quick little video to kind of refresh what a covalent bond is, how it works, and transition into the water molecule itself. Okay, so let's think about that. What effect will this have on the different areas of the water molecule? Well, based on the pole, we're going to have areas that are more positively charged and areas that are more negatively charged. Okay, it is really important, but we won't be seeing that video. We're going to move on to our notes. We're going to move on to our notes. Okay, sorry. So the essential learning statement for this particular part of the unit is that living systems depend on properties of water that result from its polarity and its hydrogen bonding. So life depends on these different properties of water that we're going to discuss. The easiest thing to think of as far as the water molecule is to use the analogy of Mickey Mouse. Very much looks like Mickey Mouse. So in this particular case, the face is represented by the larger oxygen, therefore its chin has the more negative area. The ears are the smaller hydrogens. Those are going to be the more positive areas. So when we start looking at the hydrogen bonds between these molecules, think of the chins of the one molecule being attracted to the ears of the other. That's where those water molecules are held together. So our objective from this presentation is to be able to explain how the properties of water that result from its polarity and hydrogen bonding affects biological function, affects life. So water is it's described as a polar molecule. What that means is that the electrons are shared unevenly As we know, that creates areas of positive and negative charge in that molecule. And so those hydrogen bonds form between the positive areas of one molecule, the ears, and the negative areas of the other molecule, the chin, if you will. And so those molecules are loosely held together to create the liquid water. So a few things, this follows your outline. One of the first unusual properties of water is that it is a very good solvent. It's actually the best. So remember from chemistry that a solvent plus a solute is a solution. And so organisms are basically solutions. We're 70% water. We've got a bunch of sugars and proteins and carbs and all the other elements mixed in. And so our bodies are actually in solution, if you will. And so that water is the best solvent. It's the best thing to dissolve solutes into. Other molecules are ionic or polar, and they have electrical charges which make them attracted to water. Therefore, their electrical charges cause them to dissolve in water. So those electrical charges will actually pull those ionic compounds apart, like the salt, for instance. It's going to separate the sodium from the chloride and keep it dissolved in solution. That's what I said. It causes molecules to stay in solution. Now, water is capable of dissolving lots of things, many kinds of salts, sugars, many proteins, and a variety of hormones that dissolve in our blood, because remember, our blood is also a solution. Also, oxygen and carbon dioxide dissolve in water, which allows fish and other aquatic animals to survive, being able to get oxygen from the water through the gills, or get carbon dioxide from the water if it's an aquatic plant. And that enables many algae and plants to live underwater as well. So what's the big advantage of this? Well, since organisms are 70% water, therefore the materials dissolved in the water allow for easy access by cells. Second unusual property of water is something called capillary action. A capillary tube is basically any tube of a small diameter, including the tiniest of our blood vessels. Also the xylem and phloem veins of plants. If the tube is glass, then it's polar. And that water water solution will climb up inside that tube without having to be pumped in any way, without exerting any sort of energy. It's just the natural attractiveness of the water to the sides of the tube causing it to rise. And the smaller the diameter of the tube, the higher the water is actually going to climb up in that tube. And water will climb in defiance of gravity because of this strong attraction between the water and the tube. And it's that strong attraction that is actually the capillary action. And just to prove my point, I've got a portion of a video for you. Watch this. There isn't any narration or anything. It's just this camera. And this guy's made a purple solution out of some, stuff and chemicals. We've got 3 different capillary tubes of varying sizes, and we're going to use the purple liquid to be able to watch it come up. Full disclosure, there's a little bit of focusing issues with this video, but it's fine. He gets it sorted out in the end. So here comes the first capillary tube. It has a diameter across of 1 millimeter. That's like super tiny, y'all. So I can assure you that outside the range of the camera, it's not like the guy, I'm assuming it's a guy, it's not like the guy is using the tube as a straw. He's definitely just leaving it there and letting the natural capillary action take hold so that you can see the liquid sticking to the sides. Now we're going to go with a smaller tube. This is only 0.6 millimeters in diameter. Again, apologies for the blurriness that's about to happen. Tube goes in, give it a hot tick, and you can see the purple liquid rising in the tube. It's also climbed further up than the initial tube because it's thinner. So that level rose to about 3 centimeters. The original was 1.5. So smaller tube, higher the purple liquid climbs. And now we have the teeny tiny 0.4 millimeter diameter capillary tube. So delicate. Okay, tube going in the water. and watch it go. Look at that. So that capillary action occurs when the adhesion of the liquid to the sides of the tube. That one went up to 5.5 centimeters or 5.5. So the smaller the tube, the higher the liquid climbs. Okay. So that's capillary action. All right. Our third unusual property of water is high heat capacity, something you may have learned in chemistry called specific heat. But think about this. When you go to the beach in the summer, it's like July, and you've got your cooler and your chairs and all your beach toys, and you get down to the sand, and it is hot. It's so hot. And you just throw your stuff down, and you immediately run down to the water to cool off your feet. That's because water has a super high heat capacity. So water is able to absorb lots of heat energy without much of a temperature increase. So it's not like the sand, where sand has a very low heat capacity or low specific heat, so it heats up very, very quickly. Water does not. Those hydrogen bonds hold the water molecules together quite strongly, and because of that, the heat is not really going to cause much of an increase in the movement of water molecules. Therefore, there's not going to be much of a temperature change. It takes tons of heat energy to get large bodies of water to increase even just half a degree or 1 degree. So what's the advantage of this? Well, that means that aquatic organisms who are ectothermic or use the environment, they can maintain an appropriate body temperature regulation because the water doesn't change that much. Therefore, their body heat doesn't fluctuate too much. All right, next we have surface tension. Surface tension is the result of increased hydrogen bonds between the water molecules at the surface of the water. And that water surface kind of acts like a membrane. And it is so strong that many insects, like the water strider pictured below, can actually walk on the water. So that's due to the surface tension. And then finally, ice floats. Duh, right? But the reason is because almost everything, including water, will contract when it's cooled up to a certain point. And for water, that point's about 3.8 degrees Celsius. Okay, just barely above freezing. If the water is below 3.8, the molecules begin to slow down. Okay, because remember, molecules are constantly moving. They begin to slow down. They're going to start to arrange in a crystal structure, which we would call ice. They're going to take up more space than in a liquid state, and that causes the ice to float. Ice is a very good insulator. This allows ponds and lakes to freeze without freezing the aquatic life in that water. If ice didn't float, ponds and lakes would freeze from the bottom up, which would be detrimental to the aquatic life that lives in there. It's going to kill all of them. And so the big advantage of ice floating, this allows aquatic organisms to still be able to live in water in freezing climates. Okay, this is the end of my presentation. There is a quick little checks for understanding that I'd like you to answer. Then we're going to apply our knowledge using a few diagrams. So you should pause here and continue the analysis questions, and we'll come back and check those. Okay, I'm assuming you've completed the things. If not, you really should before you continue with this video. Okay, question number 1. What's a possible solute being added to the water? Well, you've got lots of options: salts, sugars, proteins, or hormones. Those are all according to the notes. Question number 2, if the tube was wider, would the water climb as high? Negative. The water would not climb as high because it's a direct correlation between the smaller the diameter of the tube, the higher the water would climb. Question number 3, which substance has the lowest specific heat? Water, alcohol, or iron? How do you know? Okay, so remember, water doesn't heat up very quickly, so it has a high specific heat. Iron has the lowest. How do I know this? Well, they all started out at 20 degrees, and sometime later, water has gone up to 30, alcohol to 40, and look at iron, it's up to 114 degrees Celsius. So it heats up the fastest, so it has the lowest specific heat. Water would have the highest. Doesn't heat up, takes a lot of energy to move it, even just a little bit. Question number 4, why does the water strider sink? That's the surface tension. Those hydrogen bonds there at the surface with the molecule at the surface and just below act like a membrane. And question 5, how are fish and other aquatic life able to survive? Remember, ice floats and bodies of water freeze from top to bottom, thus allowing aquatic life to still have some water to hang out in and exist, even surviving extreme cold temperatures. Okay, and finally, we have a lesson skill practice visual representation. You've got the background information about what the graph is showing you on your handout. You might want to take a moment, since your handout is black and white, to mark the air, the body temp, and the water. Maybe use some different colors, or label them whatever that looks like for you. But basically, we're given the air body and water temperature of this species of fish in this river in Northern Virginia. And so you're meant to describe the property of water illustrated by the graph and describe the dependency of the Micropterus almoides, which is a species of fish that would have on this property of water. You should pause here and think about that for a moment. Now, here's the thing. If you're going to mess anything up, if you will, the graph is demonstrating water's high heat capacity, that's for sure. But the prompt says describe, not name the property. So you have to describe how the visual represents that, as opposed to just saying the graph is showing high heat capacity. There's a big difference between identify and describe. So you need to describe what the line is doing over that 6-day period. All right, and so here's the answer. Again, the graph is showing the water temperature remains relatively the same or relatively stable as that air temperature increases over a 6-day period. So it is demonstrating high heat capacity, but the graph literally shows very little change compared to the air temperature. And so a fish's ability to maintain optimum body temperature is dependent upon the water's ability to absorb heat and resist sudden changes in temperature, i.e. the fish body temperature won't change that much either, since it is dependent on the water temperature. All right, well done. And then finally, just some content takeaways. Water has one oxygen that's covalently bonded to 2 hydrogen atoms. Oxygen has a higher electronegativity, resulting in unequal sharing, so that you have polarity. You've got areas of negative charge on the water molecule versus positive charge. This polarity allows water molecules to form hydrogen bonds with other water molecules. Cohesion is the same, refers to molecules of the same type forming hydrogen bonds with each other. Adhesion is when it sticks to other stuff because of those bonds. And then finally, living systems depend on water's properties like surface tension. Excellent. Thank you very much.